Hi there, Mr. Sutton here with the AB Calculus 513 classwork solutions on average value. On this problem, we have a zoo sponsoring a one-day contest to name a baby elephant. Our visitors are depositing entries in a special box between noon and 8 p.m., and the number of entries in the box is modeled by some function e, whose values in hundreds of entries are given in this table right here. So, part A, use the data in the table to approximate the rate in hundreds of entries per hour which entries are being deposited at time 6. Okay, so we're basically trying to approximate e prime of 6. But we don't have an actual e function anywhere that's like spelled out formulaically. So we're going to have to approximate it instead by finding the average rate of change of the e function over a certain interval in this table. Now, which interval should we use? Well, let's pick one that has time 6 in it, like the interval from 5 to 7. So I'm going to just do AROC from 5 to 7 here. So e of 7 minus e of 5 over 7 minus 5. And I'm going to write, let's see, I'm writing this as the average rate of change, which is accurate. If I said rate of entries being entered equals, then I'd have to put an approximately equals there. So now we've got 21 minus 13 over 7 minus 5. And you could just put units on it and call it a day, or you can simplify this to 8 over 2, which is 4, and that's going to be, since this is a rate here, hundreds of entries per hour. They actually told you the units to use here anyway. For this problem part, they're telling us to use a trapezoidal sum with 4 subintervals given by the table to approximate the value of 1/8 integral from 0 to 8 e of t. And then, using correct units, explain what we just did. All right, so let's do the approximation first. I'm going to write that this stuff equals approximately 1/8, and then the rest of this I'll do in a sec. Note that I'm writing squiggly equals here because this is not the exact value. This is an approximation. So now that I've established that, let me launch into my trapezoidal sum. So I've got, let's see, our first interval is from 0 to 2, so we've got 0 plus 4 over 2 times a height of 2. Next, we have 4 plus 13 over 2 times a height of 3. Next, 13 plus 21 over 2 times a height of 2. And finally, 21 plus 23 over 2 times a height of 1. And you actually don't have to simplify this. You could just put the units on this. And the units, since we're taking the average number of entries, it's going to be the same units as the original, so this would just be hundreds of entries. But if you want to simplify it, it is a calculator question, so you could plug it in and waste time doing that. Let me do that now. So plugging all that in, I came up with that crazy number, which I'm going to turn into a decimal. That's about 10.688. And again, that's going to be hundreds of entries since this is the average number of entries. Now, in terms of what this really means, this is the average number of entries in hundreds, and you also have to give a time period. So this is the average entries in the box between noon and 8 p.m. For this part, at 8 p.m., volunteers begin to process the entries. They processed entries at a rate modeled by this p function here, which is some kind of polynomial. And this is in hundreds of entries per hour, and it only applies between 8 and 12 because, well, they're not processing anything after midnight. So according to the model, how many entries had not yet been processed by midnight? So this is a little bit tricky, but we're asking basically how many entries are left after they go at these entries for 4 hours. So to figure this out, we're starting with 2,300 entries, because that was how many entries you had at time 8 p.m., and we're going to be subtracting something from that now. Now, this p function is telling us the rate at which we are processing these. So you could think of that as the rate at which we are subtracting away entries from this total that we start with at 8 p.m. So if I want to figure out how many I have left, I need to do 23 minus an integral of this rate of change. I'm going to need to subtract the integral of p of t between 8 and 12. And I'll put a dt in there as well. Integral from 8 to 12 of p of t, that is the total number of entries processed between 8 and 12, so I'm subtracting that from 23. And now I've got to do that on my calculator. Now, the very first thing I'm going to do on my calculator is going to be to put this p function here in my y equals. Because this is only part C of the problem, there's a pretty good chance I'm going to have to use this again in part D. And anyway, I don't feel like writing this out every time I use it. Just writing y1 would be a lot nicer. So quitting out of that screen now, I've got 23 minus math 9 to get my integral, and I'm going from 8 to 12, and now my p function I put in y equals, so I'm going to do alpha trace to pull up my y equals menu. I'm just going to put y1 in there. It's nice not having to write all that, and I'll do this as a dx. Enter. That comes out, wow, to exactly 7. Hey, cool. So that is 700 entries that had not yet been processed by midnight. For this next problem part, according to the model from part C, which I've rewritten here, at what time were the entries being processed most quickly? Justify your answer. So we're essentially trying to find the absolute maximum value of this p function on the interval from 8 to 12. Okay, so to do that, we're going to need critical values. We're also going to need to test out the endpoints 8 and 12 in this function. And I've already got this in my calculator, so that won't be too difficult. But let me get critical values. Now, in order to get credit for my work on this, I need to actually find the derivative and write it out. I can't just say, hey, I looked up p prime in my calculator, and here's what it says. If you're solving a derivative for certain values, you need to write out the derivative. So p prime then is going to be 3t squared minus 60t plus 298. And I'm going to figure out where this crosses the x-axis. That'll give me my critical values. So I've entered p prime in my y2, and I actually don't want to have y1 selected because I don't want to graph the original function. I just want the derivative here. So I'm going to graph that on the interval from 8 to 12. So let me go to Window, and I'm going to put 8 to 12 as my window here. And now let me do zoom 0, zoom fit, to see where I'm crossing the x-axis. So it looks like I'm crossing in 2 spots. Now, before I waste time looking up both of them, since I'm looking for a max, I only have to consider local maxes. So I really only have to test out critical values where my derivative is going from positive to negative. I do have to spell out that that's the only place it's going positive to negative, but once I've done that, I can avoid testing any other values. So let me find this particular x-intercept here. I'll do second trace and then 0, and then this looks like it's between 9 and 10. And then I'll press enter one more time. Whoops, maybe not. Okay, let me try again. So sometimes you just need to move the spider here. So there we go, a little bit to the left, a little bit to the right, and now my calculator's behaving. We get about 9.1835 and some change, and I'm going to actually store that value. So I'm going to X out of there and store that value as alpha A, or whatever you want to store it as, so that way I can come back and use it whenever I want. Okay, so now what I'm going to write down here is that this function changes from positive to negative only at A. I'm actually going to name my variable here, or name my constant here, at A equals T, approximately equal to that number I just found on my calculator. So now what I've done here, I can refer back to this number by just writing A on my calculator and my paper without having to write it all again. Okay, so now that we've got this one critical value that I have to test, I'm going to go through and test that along with the endpoints in the p function. So this is the candidates test here. So first I'm going to try p of 8. So to do that, I'm going to do, let's see, alpha trace and pull up my y1, because that's where my p function is. And I'm going to plug 8 into that, which gives me a value of 0. Okay, so that's not a very good candidate for the maximum value. The entries aren't being processed at all, apparently, when that time starts. Next, I'm going to try P of A, or P of this 9.1 business. So going back into my calculator, I'm going to yank my input from before, and I'm going to put alpha A in there now. And that gives me about 5.0887, which is a little bit better. But, let's see if we can do even better at midnight. So now I'm going to try P of 12. So I'm going to go back, yank that input, and now I'm going to put 12 in my p function. And that's even better. That's a rate of 8. So it appears now that that's going to be our maximum value. So in terms of writing this out and saying what it means, the entries were being processed most quickly at midnight because, they had a head of steam and they wanted to be done with it. For this problem, if the average value of a continuous function on the interval is 12, what is the integral from negative 2 to 4 of f of x over 8 dx? So the tip-off on this one, this is kind of a weird problem, but the hint on here is they're talking about the average value of a function. And this looks like it has kind of elements of maybe the average value in it. So I'm going to actually write out the average value for this f function they're talking about. The average value is going to be 1 over b minus a, which in this case is 4 minus negative 2, of the integral from negative 2 to 4 of f of x dx. And they told us that that equals 12. So based off of that, we're supposed to figure out what the integral from negative 2 to 4 of f of x over 8 is equal to. Well, it might be easier if I at least figured out what the integral from negative 2 to 4 of f of x is equal to, and then I can just divide that by 8. So right here, I've got 1 over 6 here. I can isolate this integral from 1 over 2 if I just multiply both sides by 6. So that allows me to write the integral from negative 2 to 4 of f of x dx equals 72. Now, how does that help me? Well, I'm almost there, because in order to turn this into this, I just have to essentially divide it by 8. You could rewrite this function up here as 1/8 times the integral from negative 2 to 4 of f of x dx. Because if you're dividing by 8, you really have a multiplier of 1/8 in here that you can pull out. And hey, we actually know what this integral's value is. We wrote it up here. It's 72. So really, I'm just doing 1 over 8 times 72, which I know comes out to 9. So that's choice C. On this problem, f is a continuous function, and g is a function defined as g of x equals the integral from 1 to x of f. If the average rate of change of g is 6, which of the following statements must be true? So the key on this one, because they're giving us a whole bunch of statements involving f, g prime, g, the key on this one is realizing that g prime equals f of x, and that's just our fundamental theorem of calculus, taking the derivative of an integral with an x in the upper limit. Well, what this means, since g prime of x equals f, f is the rate of change of g. That's what this is saying here. Now, if I want the average rate of change of g on the function, since f is the rate of change of g, if I want the average rate of change of g, I just need the average value of f. So the average value of f is going to be the average rate of change of g. What that means, since they told us the AROC for g was 6, that means by extension that the average value of f is going to be 6. And that is exactly what they are saying in choice A. So we're going to pick that one and be done with it. On this problem, which is a no calculator question, we're trying to find the average value of cosine from negative 3 to 5. So using our average value setup, we have 1 over b minus a, so that's 1 over 5 minus negative 3, times the integral from negative 3 to 5 of the cosine function, cosine of x dx. Okay, so I've got 1/8 then, and now I need the antiderivative of cosine, which I'll evaluate from negative 3 to 5. That's going to be sine of x from negative 3 to 5. So I can write this as 1/8 times sine of 5 minus sine of negative 3. But I'm trying to match one of these answer choices. So I can get a little closer to matching an answer choice if I make this sine of 5 minus sine of negative 3 over 8. That would at least eliminate choices B through D. But, what do I make of this sine of negative 3 business? The key on this one is realizing that sine of negative 3, since in general the sine of a negative angle equals negative sine of that angle, because sine is an odd function. That's just how sine works. If you realize this, then you realize that you can rewrite this as sine of 5 minus negative sine of 3, or plus sine of 3. And I'm going to write that over 8 just to make it look like one of the answer choices. That's going to give us answer choice E. On this calculator question, we're trying to find the average value of this crazy function on the closed interval from -1 to 3. So using my average value setup, which I'll then plug in the calculator, I've got 1 over b minus a, so that's 1 over 3 minus -1, times the integral from -1 to 3 of, and just this function up here, so I'm just going to write y, because that's what y equals, dx. Okay, so now let me go ahead and plug this in the calculator. So when I actually plug this in the calculator, of course, I'm going to have to put the actual function, unless I want to put this in the y equals and then put y1 there, but that's kind of an extra step since I'm only using this function once. I've got a 1/4 out in front, integral from -1 to 3 dx. Let's see what this comes out to. And that's going to be 0.183 if I round that off. So that's answer choice C. On this problem, we have the graph of f and these regions A, B, and C that they're actually telling us the area for if you read more closely. We want to know the average value of our f function on the interval from 0 to 8. So just setting up our average value setup here, we've got 1 over b minus a, so 1 over 8 minus 0, times the integral from 0 to 8 of f of x. So that's going to be 1/8 times, and now we actually have to integrate the f function, which is to say we have to find the area under the curve here. So the nice thing is that they actually gave us all the areas we needed. We're going from 0 to 8, so we're just going to take all these areas and put them together. Now I'm going from left to right, that means that anything above the x-axis is going to be positive area, and anything below the x-axis is going to count as negative area, going left to right. So I've got the area A, which is 14, so I'm going to open a parentheses now. So I'm going to have 14, and now the area for B was 16, but that's below the x-axis, so I'm going to subtract that. And then finally, the area C is above the x-axis, so I'm going to add 50. We do need to simplify this because this is multiple choice. So all the stuff inside here, let's see, that's -2 plus 50 is 48. 1/8 of 48 is 6, so that's going to be choice A. On this calculator question, on a certain day, temperature in Fahrenheit in a small town after midnight is modeled by this function. We want the average temperature in the town between 3 a.m. and 6 a.m. So this is just a set up the integral and plug it in your calculator kind of problem. For average value, we start with 1 over b minus a outside the integral. So that's going to be 1 over 6 minus 3. And then we're multiplying that by the integral from 3 to 6 of this g function here, which I'm not going to bother rewriting. I am going to have to write it in my calculator, though, so let me go ahead and do that. So let me just show you what I have written here. 1 over 6 minus 3, here's my integral from 3 to 6. Here is the rest of the stuff in my integral, and I used that fancy fraction, alpha y equals, to get that going on. dx, don't forget the differential there. Pressing enter, that comes out to 57.797. That's degrees Fahrenheit. So just carefully pick your answer choice here because these all kind of look similar. That's going to be choice B. For this no calculator question, we're trying to find the average value of this piecewise defined function between -1 and 1. So in general, average value, that's going to be 1 over b minus a, so 1 over 1 minus -1 in this case, times the integral from -1 to 1 of f of x dx. But the problem is this interval involves a border value, so we're actually going to have to split this up into two integrals. So this stuff out here, that's a 1/2, and now I'm going to have a parentheses. I'm going to have the integral from -1 to 0 of this first rule, 1 minus 2 sine of x dx, plus the integral from 0 to 1 of my second rule, e to the -4x dx. And now let me go ahead and take some antiderivatives. So I still have that 1/2 out in front, and I've going from left to right for this first antiderivative. I've got an x minus, well, let's see now. The antiderivative of sine is negative cosine, so this is going to be plus 2 cosine of x, and this is being evaluated from -1 to 0. Next, I've got the antiderivative of e to the -4x. That's going to be e to the negative 4x divided by the tail here, so times negative 1/4, and that's being evaluated from 0 to 1. All right, so I still have my 1/2, and now I'm going to plug 0 into this stuff, so 0 plus 2 cosine of 0, minus all this stuff with negative 1 plugged in. And over here, I've got this stuff with 1 plugged in, minus this stuff with 0 plugged in. And this is just a big mess. If I wanted to, I could try simplifying it. I mean, 0 and 2 cosine of 0, that doesn't look too hard to simplify. But if you keep looking here, you'll notice we have a cosine of negative 1, which doesn't really simplify to anything. This is some weird decimal. So because we have all constants here, we don't actually need to simplify any further on a free response, and we could leave this as a final answer and call it a day. And that's what I'm going to do.